So we've been making these list of rules. We're up to, I believe, 4 rules so far. We talked about the derivative of a constant function, the derivative of a linear function, a power function. We talked about, more importantly, the constant multiple rule and the sum and difference rule. So the constant multiple rule says if you're multiplying by a constant, you can just pull that constant out front, take the derivative of the variable part, and then multiply the constant in at the end. And then the sum and difference rule says if you're taking the derivative of a sum or of a difference, you can just take the derivative of each piece separately and then just add them together or subtract them when you're done. So it seems like if you were taking a product or a quotient, it might be the same thing. Like the product of their derivatives would be the same as the derivative of a product, and same thing with quotients, but it's not. So, for instance, if we look at this one right here, the derivative of x times x, we know, of course, that x times x is x squared, and the derivative of x squared we got through the power rule, where the 2 comes out front, and then x's power drops down to 1, which is, of course, just a 2x. But if we're looking at these two separate pieces, if we took the derivative of x times the derivative of x, the derivative of x is just 1 because it's linear. So that would be 1 times 1, which of course is just 1. So the derivative of x times x came out to be 2x, while the derivative of x times the derivative of x came out to be 1. So hopefully you can see, even just from this small example, that this does not work the same way that the sum and difference ones work. So the derivative is actually the sum of 2 different products. We have this formula that we follow, and if we look on this next page, we can write down what is called the product rule. So this is something year after year that people just end up forgetting. So we're going to spend a lot of time on this, make sure we know the product rule forward and backward. For some reason, even in like April, I have people that are still doing just a derivative times a derivative, and it's not. It's got a very specific formula. So it goes like this. So say we have a function u and a function v. If we want to take the derivative of u of x, which is our first function, times v of x, if we're taking the derivative of that product, what we do is we take our function u and then multiply it by the derivative of v, and then plus the derivative of u times our function v. So there's a proof. I'd rather go through that proof during class, so for now let's just skip over it. But this is the product rule, and we could prove it, not really prove it in general, but we could prove it kind of case by case by looking at a specific example. Like if we wanted to see, for example, what the derivative of x times x was, we know it comes out to be 2x. So let me show you, just for example. If we consider this function to be x and this function to be x, obviously we can multiply them together and get x squared, and then we can just do the power rule really quickly, but I want to show you that it fits in here. So if we use the first one as x, so that will be x times, and then the derivative of the second one, which is x, so the derivative of x is 1, and then plus the derivative of the first one, so the first one we're considering it to be x, so that derivative is 1 times, and then the second function, which is again x. So this ends up being 1x plus 1x, x plus x, which is 2x. So this does in fact work. That's just kind of a little side note there. Again, the proof we're going to skip over for now. So let's look at this first example. So we want to find the derivative if f of x is the product of those two things. So now notice, there is something we could do to kind of verify that our product rule is working. We could take that and FOIL it out, which is something that we did in the previous set of notes. But for now, it's like, hey, you know what, I might as well. So here's what I would like to get you guys in the habit of doing. I would like you to write out the first function, which is u, and then I'd like you to write out the first or the second function, v, and then kind of keep a little note of what the derivatives are. So if this is u, then u prime, we're just taking the derivative of this expression right here. So the derivative of x squared, the 2 comes out front, and then x's power drops down to just a 1, which we don't need to write, and then plus the derivative of 1, which remember the derivative of any constant is just 0. So the derivative of this thing right here is just 2x. And then v prime, so we can use that in the formula. The derivative of x cubed, the 3 comes out front, x's power drops down to 2, and then the derivative of 3 is just 0, so we don't need to write anything for that. So f prime of x equals, if we're writing down this derivative, we start with u of x, so the original function u, which is x squared plus 1, and then times v prime, which we've got written right down here, is 3x squared. and then plus u prime, which is 2x, and then times v of x, which is x cubed plus 3. So we never ever want to leave it like that. So we want to do some distributing, some combining of like terms. So if we work right here, distribute the 3x squared, so we get 3x to the 4th plus 3x squared. And then plus here, distribute the 2x, so we get 2x to the 4th, and then plus 6x. So here we've got two terms that have an x to the 4th, so we get 5x to the 4th plus 3x squared, and then plus 6x. So if you're ever wondering, like, does this answer work, you can always take a look at this, FOIL it out. Like the first term, for example, if we FOILed out x squared times x cubed, that would be x to the 5th. The derivative of x to the 5th would give us 5x to the 4th. This next term, we'd have an x squared times 3x, which is 3x squared. The derivative of that would be my 6x. In the middle, I'd have an x cubed. The derivative of x cubed gives me 3x squared. And then last, 1 times 3 is 3. The derivative would be 0. So you can kind of double check that the product formula actually does work by just foiling it out and checking. So that's what I've been writing down right there, is that you can multiply it out, FOIL it out, and then differentiate each piece. However, when we're working with something like e to the x, it doesn't really work out like that. So let's write down all the same rules, or all the same pieces that we just wrote down here. So our original function u is x squared. Our function v is e to the x. So the derivative of x squared is going to be a 2x, same derivative we wrote up above. And then the derivative of e to the x, remember we wrote that down, best derivative ever. The derivative of e to the x is just e to the x. That's one that hopefully you guys will remember for a while. And then my product rule, y prime, we've got the first times the derivative of the second, and then plus the second times the derivative of the first. Or in the formula, it's technically written as the derivative of the first times the second. But in my head, I always run through, instead of using u and v, I've always said the first times the derivative of the second plus the second times the derivative of the first. Kind of keeps everything straight in your head. And then for this, if we were to simplify it up, you could always factor out an e to the x if you want. And then you'd have an x squared plus 2x left in parentheses. So that would be your derivative of that function. So of course, remember, while we're talking about derivatives, I don't want to get just so caught up in, oh, here's what the derivative is, this is how the formula works. I want you to remember each and every time that a derivative represents a slope. So if you were looking at this function right here, if you wanted to know the slope at any specific value of x, you would plug it into this formula, and that's exactly what you'd get. Okay, so another side note here, just like we were talking about with the product, there is a specific product rule. There's also a specific quotient rule. It's not just the derivative of the numerator over the derivative of the denominator. So the quotient rule, and again, here we need to be very careful about this. The denominator can't be 0. We know that. If we're taking the derivative of a quotient like this, the quotient rule ends up being, so we've got the derivative with respect to x of this quotient, so u of x divided by v of x. So this is the rule. You guys are going to love it. We've got v of x times u prime of x minus u of x times v prime of x, and then all of that over the quantity v of x squared. Okay, so this one's definitely kind of a crazy formula, and I don't love the u's and the v's. The book uses u's and v's. I think that u's and v's look very similar, so I guess when you're writing it, just be very careful that your u's are more curved. So this is a formula, very, very nice. There is a proof. We will also discuss that in class. The cheesy memory trick. Here we go. So if we consider these to be, we call the numerator high and we call the denominator low. You know, the lower function and the upper function. So this is something that I learned in high school. We talked about it in college as well. So the cheesy memory trick, we write low d high minus high d low. Oops, there should not be an I there, sorry. All over low, low. So let me walk you through that. So low is the lower function right here, and then d high, remember d, we always use like d by dx stands for the derivative, so low d high, that's the denominator times the derivative of the numerator, and then minus high d low, so the numerator times the derivative of the denominator. Oh, that's where my I went. Let's try that piece again. There we go. So low d high minus high d low all over low low. So the denominator times itself. So low d high minus high d low all over low low. So we'll say that over and over again in class. Believe me, that will help you to remember it. You'll still be saying it in college calculus. So the derivative here, again, we're going to keep everything all written out so we can keep ourselves organized. Now, it's not super necessary now, but eventually we'll get functions that are so complicated that we're going to want to keep track of this over on the side, so we're going to get in the habit now. So u prime equals 2x, v prime equals also 2x. Notice here you've got these constants, and so even though you've got different constants, your derivative isn't going to change. So another thing you might want to get in the habit of, you could write high, low, d low. That way you can just keep the cheesy memory trick in mind. So f prime of x, we've got low d high, so low is x squared plus 1. D high is 2x. Not the worst idea to write those in there. High, low, d high, d low. So low d high minus high d low, all of that over low low. So x squared plus 1 quantity squared. Okay, so as always, we're going to simplify this up. So here's what we've got going on here. We're going to distribute the 2x, so 2x cubed plus 2x. Now make sure you're keeping these quantities separated and in parentheses. And then minus, we're going to do the same thing here. So 2x times x squared is 2x cubed, and then minus 2x. Again, we're super careful. These things are in parentheses. Notice that these two cancel out. I've still got my denominator of x squared plus 1 quantity squared. Now, very carefully, we are subtracting a negative, so we've got 2x and then technically plus a 2x. So this ends up being a 4x in the numerator over x squared plus 1 quantity squared. So that's your final answer, but just like I said with the last one, remember, keep in mind that what we just found was the slope at any specific value of x for this function right here. Okay? Example 4. Last one here. This is something that the AP test loves to do. They don't give you functions or anything like that. They just give you specific values. So we want to find the derivative at x equals 2 for a product function and a quotient function if all they give you are these specific values. All right, so if we wanted to find, let's label this one z, just so we can keep everything kind of separated. So if we wanted y prime, we just have u times v, so all we're going to do is just do the product rule, kind of write it out once. So the first times the derivative of the second, and then plus the second times the derivative of the first. So if we plug all that stuff in, now notice it says at x equals 2. All of these are the function value at 2, the derivative at 2, the function value at 2, the derivative at 2. So we plug those values right in. So u is 3 times v prime, which is 2, and then plus v, which is 1, times u prime, which is negative 4. So 3 times 2, of course, is 6. 1 times negative 4 is negative 4. So for the product, we end up getting a value of 2. For the quotient, now again, it's better to use a different variable, something like z, so you can distinguish the two. So we've got low d high minus high d low all over low low. So now plug these values in. So v is 2 times u prime, which is negative 4, minus u, which is 3, times v prime. Oops, I'm sorry, I grabbed the wrong value there. V is 1. V prime is 2. And then over v squared, so that is a 1 squared. So let's simplify this down. 1 times negative 4 is negative 4, minus 3 times 2 is 6, and then over 1 squared, of course, is just 1. So negative 4 minus 6 is negative 10, over 1 still just leaves us with a value of negative 10. All right, so we'll talk about some of the other details on those notes tomorrow. But for the most part, just start memorizing those rules. Product rules, quotient rules, very, very, very important.